Let's see. I have to confess that this morning I went to the Ceph users meeting instead of going through the pull requests, so I don't have anything prepared for that this morning. But Adam and I have been spending a lot of time this week talking about how shared blobs work in BlueStore, and so I imagine we'll probably discuss that quite a bit today. Um, Maybe before we get into that, though, I'll open it up for other people. Uh, is there any topics that people would like to bring up today? Or are there any topics? Sorry. All right. Well then, all of this comes out of the work from the RBD mirroring performance issue that was seen, that we've been talking about quite a bit. Um, the gist of it is that the work I had been doing to try to see if I could improve the performance of iterating over extents, it kind of worked. I was able, Casey, your idea was good regarding the movement constructor. That did work in the end, or at least it somewhat worked in the end at the very least. Enough that I was able to run normal benchmarks fairly fast. In fact, it generally, just for doing normal benchmarking in BlueStore, it looked like maybe we got even like a 5% CPU usage reduction with at least similar performance levels. So a win. But I ended up with really, really irritating, strange issues with reference counting in other parts of the code that Adam and I sat down and tried to debug and theory out, and it turns out that it didn't look like this was really doing a whole lot for the issue that we were hitting with snapshots, and so that kind of got put on hold and maybe abandoned. We'll see. But we ended up looking at the ref map inside shared blob, and Adam, I'll let you talk about everything that you've discovered. I'll just say I did go through and try to replace that with I did actually successfully go through and replace that with a flat map and got all the iterator and validation out. And that runs fine now, seemingly. The downside is that the benefit is pretty small. I've got the numbers in a spreadsheet here. It's linked in the chat window. You can kind of tell that it's helping a little bit. The yellow line, or the yellow peaks, are the ones using flat map for the ref map versus using the original standard map. And this standard map is for every single shared blob, and we have a lot of them per object in this kind of workload. And that shared map, or that ref map, is basically just storing like eight bytes of data. It's ridiculous. It's tiny. There's lots and lots of those maps. But that's starting to get into the stuff that Adam discovered. So Adam, do you want to talk about the things you were working on and what you saw?
Yes, sure. Just a bit out of focus with browser. I tried to find my PR, maybe later. Basically, most of what I've done recently revolves around earlier work that I did about just printing ONode metadata, internals, because I knew what the structure of the data is, but how actually it's being used was unknown to me. So I made an example, a tool that allows me to print exact metadata as it encodes objects. That allowed me to see few strange things, like very inefficient encoding of checksums, also inefficient encoding of extent. Basically, bad prediction was used there, and so on. I mean, those are elements that cannot be fixed without modification to encoding, so that was left for later. But the same tool basically clearly let clearly observe that when we modify object that is shared, meaning we have some, let's say, already shared object. A shared object here means that we already did a snapshot of it. So blobs that are in the object are already shared. So when we write to head object that has a snapshot, obviously we replace some range with a new data. Interesting thing happens when we make next snapshot of it. Basically, we take the new data, we pack it into separate shared blob, even if that's just a 4K, and then we make a copy from head object to clone object. If you think about it as a one-time operation, it makes perfect sense. That's exactly what you should do. But the test we were tackling was that we had an object that we modified, and we already made many snapshots. We just made one snapshot, write some data, made another snapshot, and so on. It means that the effect that we have new blobs that basically cover only data modified in a specific period between snapshots, just a sequence of that shared blobs. That still is not so bad. But when we delete, because when we have all the snapshots, when we are still required to have all snapshots, then we have to somehow maintain the data. And that might be proper way to do it. But we delete the snapshots. In the test we have, and it looks like a reasonable real life case, we delete some old snapshots. And the effect is that we do get more and more fragmented blobs that we cannot merge because we lack information that now some blobs that are basically adjacent one to each other, each has, like, let's say 5 reference counters, but we do not know that they all belong to the same line of object. So that's the background. I made an attempt, just a simulator, to show what will happen if we reused some free space in the blobs. Oh, Mark, thank you for.
Yeah, it's the one. Yeah, it's just the one I did, but I didn't have yours handy, so I just.
I will share my result of a simulator. Basically, the effect is we can get rid of that additional blobs and keep number of shared blobs, like 5 when you have 5 copies of an object in reasonable for reasonable intensity of random writes. That was the starting work. Now, with So one concept was to modify duplicate, extend map duplicate function, so it will try to find a place in already existing blobs instead of always creating new shared blob. That's one thing. And then with Mark, we continue how to even simplify data structures around shared blobs. Basically, you might not know, but what we currently have as a shared blob entity in X column in RocksDB does not track blob at all. The object shared blob is basically only a tracker of how many times specific region of the disk was used by shared blob. It means you could have like, and in addition to that, each object that's referencing the shared blob is having its own encoding, entire encoding of a blob. It's a speed up for read cases when just after you read object metadata, you can read data. You don't have to reference some additional keys from RocksDB. That's it. And for write cases, when you modify object, you modify your local blob, and then you notify shared blob that some references might have been unused. And of course, if ref counter goes down, the else case is not important at that moment. So we are trying to maybe simplify the case here by attempting, I don't know, maybe, various ideas. I had today one that is either stupid or ingenious, to let disk allocator actively count references. So that would be like a case when object is no longer referencing part of shared blob, it will just release data and be done with it, and allocator will behave appropriately. So, yep, that's it. And now let me find and copy results of simulator, how amount of change shared blobs changes.
While Adam's doing that, Igor, some of the things we've also talked about is whether or not we could, well, I suppose if we removed compression from blob, whether or not it would allow us to not keep track at the byte granularity anymore, but if we could do it at the min-alloc size. You probably know this code better than anyone, I think. What are your thoughts on all of this?
Not sure I'm ready to answer immediately, so maybe better to
we also actually don't want
check it offline.
We need more precise counting than the malloc size sometimes is, because like RBD, when RBD like does a partial write and then looks for a hole, we need to not lie about that.
Sure.
But
and that can be smaller than a min-alloc size.
Even if min-alloc size is 4K, I mean we need granularity less than disk log size.
I don't remember exactly which use cases get relied on, because it worked, and so things started getting built. A couple of things were built on top of it. What I know of is the FS crypt integration in Ceph, and I think that's been adjusted to be less fussy now than because we discovered that some OSD configurations did behave differently than we thought. But in particular, the min-alloc size is a user configurable thing, and it has in the past been like 64 kilobytes, and it definitely needs to be finer granularity than that.
Yeah, I mean, I don't think we're planning on going back from 4K up unless nothing else works.
I mean, yeah,
I think
but a user can do that, and a user config setting like that can't just break things. So, I mean, it may not need to be like granularity, but we would need to talk, and that definitely can't be like just min-alloc size is probably larger than we can assume. Now, it might be that the benefits are worth it, and so we need to have that discussion. That as a warning, like we can't merge that without testing
Yeah.
all the other things and discussing
Sure.
them.
Okay, Adam, I see you've pasted a whole bunch of stuff.
Those are links to simple simulator of how many blobs we will use if we allow ourselves to integrate a newly added local blocks into some shared blobs that we already own in an object. That's, of course, relates to a process of making extent map dupe, so the snapshot moment. Okay, let me explain how you could read that. Try to be. The sequence is the name is how many like 16 reuse. It's how many allocation units are per blob allowed, and the sequence you can read it like this. There is a sequence of iterations, and first there is a part that simulates write, and here we see wave sign that marks where we write new element. Then there is a snapshot, and when snapshot happens, all newly written data, the spaces means empty holes. So when we do snapshot, first snapshot, A letters say what is the shape of our shared blob and which segments it represents of region. And we can see in dump of blobs that each region of the shared blob now has two references. And it goes on and on. And when we try to, we would need to go some way down.
Adam,
Yep.
is it worth sharing your screen, or would it help if I shared the screen?
Okay, I will try to share my screen. It not always works. That's the problem.
Sure.
Okay, and for other people, that's the first link from the four I shared. The sequence is the simulator is like this. It goes in 50 iteration. Each iteration is first trying to write some random data to object, basically 16 times allocation unit in size. That's all that's interesting. And in between there's a write phase and snapshot phase. You can see that the places where we in the first write we put some data are converted to shared blob now in both objects. Object H, which is head, and object 1, which is a snapshot. Snapshot number 1. And there is a dump of content shared blobs. Only one shared blob named here A. Then second iteration, we write something, and then we do snapshot. Here, after snapshot, we have two objects, the previous head object, previous snapshot, and new snapshot. We can see that the reuse strategy used the same object. I will show how it looks in a different case when reuse is not in effect. That's it. The same simulation, when reuse was not enforced, you can see in line 18 to 20, new blob appeared. So in that case, where previously we could reuse some space of the same blob, now we had to create an entire new blob. And that's the case how we do it now. That's the current way BlueStore extend map dupe works. And basically you can just scroll down to see how it causes continuous increase of amount of shared blobs. And yep, I mean, I could share source code of the simulator. There is nothing much there, but it's really not interesting. The question here is, what will be the effect of performance when we reduce a number of shared blobs? That is something that I think we do not know, and I don't think we could do analysis without practically implementing it and testing. That's my take on it.
I agree, Adam. I don't think we can guess at it. There's too many moving parts here. It just, I mean, the fact that we'll have more extents in the ref map per shared blob means that the characteristics are going to change dramatically compared to what they are now.
And one more thing I would like to show at that point, which is not really obvious. If the blob size is larger, no, that's the case we do not reuse, that case, reuse. We even end up with less blobs than with smaller blob size. That's actually predictable outcome, since if there is a larger size of blob, there is more ability to find some blob that will still be matching. Oh, I forgot to say one limitation. The algorithm only tries to reuse the blobs that they were already used in encoding of the current object. So if there are some blobs that are not the part of actually used set, they are skipped in finding attempts to find space in that those blobs. Yep, guys, that's what I think about it. If any questions, so I can explain better.
So Adam, would it be a good time to talk about the profiling results that we looked at? Is that useful, do you think?
Yes, I think so.
Okay, let me open those up then. So, Windows open. The link in the chat window. Is it worth sharing my screen for this? gonna have to be pretty wide, I guess. All right, I'll try.
And to some degree, we are talking about this in a bit wrong order, because what I did was a result of us looking at that exact performance graph you will show us now.
This is strange. Trying to figure out how to make it share the screen is not behaving the way I expected it to. It's never done it this way, but it's asking me to select from a list of windows, and now I'm having to search through all this entire list of windows for the one I want instead of just clicking on it. That's strange.
I tried to do the same, and I ended up with entire screen.
Huh. Yeah, and I don't even see the one that I wanted to share, or I don't even see how to share the whole screen now. It's like they changed this somehow. Maybe if I break this off into its own window, maybe it will show up. Try again. I have to click on a lock icon. It's all very okay. Allowed. Sorry, this is taking so long. This is not very working very well. Oh, okay. I'm gonna give up on this for now. It's has permission problems as well, apparently. So anyway, I guess you can look at it in the chat window there. Okay. So the reason that the reason I was looking at the ref map specifically this week was that if you kind of scroll down in this thing to like line 78, you can see the BlueStar sent ref map T put call, and there are some get calls scattered around here as well. So that was the effort to try to see if we could make some of that a little faster, and it maybe did help. This, for reference, is the version from the flat map. So this particular trace already has the flat map improvement. It's very slight improvement in place, but there's a lot of other stuff going on in here too. Definitely management of intrusive pointer references. There's some encoding and decoding in here. Creation of old extents. Fault range is taking up some time. Opening shared blobs. There's decode, blob decode. The gist of it is there's a lot going on in here. I mean, it's not just one thing. It's just the sheer quantity of extents and shared blobs and other data structures that are involved when we have a lot of fragmentation across the snapshots. It's just there's a lot going on. So like if we need the byte level granularity, I don't know. I guess if there are ways that we can reduce the quantity of data structures that we're dealing with, that would probably help us. Short of that, it's going to just take a lot of optimization in a lot of different areas, a lot of really small gains that maybe they add up to something. I don't know, but that's what it looks like to me now. Adam, what do you think? Anything? Did I say anything wrong? You think, or do you agree or disagree?
I think we should simplify data structures we have in BlueStore now. Specifically, that some of the cases we use them don't really make much sense. For example, we correlate buffer cache with shared blob. That gives us ability, if we read one head object, then we could read a snapshot object from the same cache. That's of course, performance benefit, but how often do we actually expect that snapshot object will be read at the same time as head object? And getting rid of that, we could move buffer cache from, of course, that's an example of simplification we could attempt, from shared blob level to maybe object level. Just O-node level.
Sure.
Yeah,
and then the idea is
like
that
ref also that Mark already looked recently, ref blob ref map T, that is a full map, basically in most cases contains only 4 elements. So again, simplifying that would be huge benefit. And so on.
If I remember right, in shared blob, the buffer space, was that a pointer to buffer space that contains the map of objects or cache shards? Is that right?
No, it's actual object.
It's actual
that
object.
keeps objects that keeps intrusive pointers of buffers, and yeah, and
Okay.
uses then relationship to buffer space cache, which is a collection level, I guess, LRU cache for all the data.
So we would save some by having it at the object level rather than at the shared blob level.
If we attempt to do that, we could strip shared blobs from possibly shared blobs facet from blobs that basically are regular blobs. Because now the only way of cache data, we cache data in regular blob by creating their view as a shared blob, and then we add it to cache.
Yeah. So from our previous conversation, it looks like once upon a time we didn't actually require that the blob reference to shared blob, but now basically it just always happens. We even have code that doesn't check for it and just assumes it's there. But we have some old code that actually doesn't check to even see if it exists or not.
Yeah, that's true. The place when we can see that we now assume it's always present, it's read cache, which iterates over extents in objects, and all extents that are present we just assume that shared blob does exist. We just dereference and there is no ifs.
Yeah. I wonder in this case this kind of pathological case that we're looking at right now, if we'd really end up with very many fewer shared blobs at that point, though. Man, we'd have some for a while, right? We wouldn't need it for any regular blobs, but eventually, like, everything becomes a real shared blob, right? Because of in this case, like, the volume has pretty much every single blob ends up becoming a shared blob because of the random write pattern plus the 5 snapshots being kept.
Well, again, sorry guys, I get noise from. I'm thinking that maybe we should be extra careful not to optimize for some pathological case, like basically the one that we are analyzing now with Paul's testing.
Well,
and not oversimplify for such case. I mean, over-optimize for such case.
It's a real case, though, if you're using RBD mirror, right? Because it's always doing snapshots. Right? It's regularly doing snapshots, and if you're writing small random writes to the volume, I mean that's basically Paul's case, right?
Yeah, okay, I mean, if RBD mirror does work that way, then that's a real life case.
It is, unfortunately. It's a bad real life case, but it's a real one. Unless we go back and just say snapshotting is the wrong way to do this, right?
But still, we will need to have some copy on write. We can use the very severe snapshot example as a good testing point for efficient copy on write and deletion of superfluous copies after that.
Gabby, are you trying to say something? I don't hear you. It's like I see the screen is telling me that you're trying to talk, but nothing's coming out. Yeah, sorry. Adam or anyone else, do you hear anything?
No, I only heard a strange noise from Gabi.
Yeah.
I guess I was trying to deduce from code and from old PRs, thanks Mark, by the way, and maybe some documentation if I found it, what was actual goal of current architecture of shared blobs, because I definitely don't want to cut down some functionality that it's not implemented but I should implement it one day. And on other hand, I would love to cut down anything that we will not practically use and is just a leftover burden from past era.
Well, in this respect, I would definitely prefer to leave current implementation as is, and maybe experiment with a clone of it or something started from scratch, because making significant modification to existing code is pretty complicated, and if we want experiments like that, maybe introduce some BlueStore version 2, then we might want to fork some point and market it as experimental and it with that.
Igor, do you remember back when we actually implemented blobs in the first place? Adam had when we were looking at some of the old code, he actually saw that we previously had the ability to share extents, and I don't remember how any of that used to work before blobs.
Unfortunately, I don't recall anything about that.
Okay. It all happened very quickly. I feel like it kind of as the transition from new store to blue store, we changed a lot of stuff really fast. I don't really remember why, what our thought process was. So Adam, what do you think about that? About just like trying something like kind of totally different?
I like trying different in a separate branch because I will not break a currently working project. But on the other hand, if the new stuff is highly divergent from original, it will be difficult to like get it back together. So my preferred way of solving problems will be try to find out small things that are still compatible and just try to modify.
My idea is that if we want to make some severe changes to BlueStore, we might want to have a fork and proceed with all modifications in that different implementation, leaving current one as is. Again, that's for severe changes. So I would recommend to avoid changes to exist.
Okay, now I have to ask, what do you, Igor, rate as severe change?
Well, stuff like removing some functionality, some significant data structure redesign. Like that. I mean, well, maybe I'd say something like that. So if we are fixing a bug, that's fine to go in the regional branch. If we want to do some redesign, then I would suggest to consider that as a version 2 implementation.
Adam, I don't know what you'd think. Do you think that the behavior with like CRC that you saw, would we classify that as a bug or as a design detail?
No, that I would rate as a bug.
Okay.
Igor, I found out recently that when we encode CRC for blobs that have like 32 kilobytes whole in front and then 4 kilobytes of actual data, then when we encode CRC, we basically dump into metadata 8 entries for that 32 kilobytes, and then 1 entry of actual data. And that was very severe metadata consumption place for that polls test, when we suddenly get a lot of shared blobs just containing 1 allocation unit modification.
Yeah, I see.
It seems to me like that's the kind of thing that we should probably try to fix in the current code. But maybe some of these big ideas regarding drastically changing things, maybe that would be better to do in a more isolated, especially if we're changing on disk format, I guess. Adam,
that's what I'd like to mention as well. So if we update metadata structure, that might be considered as a severe change, severe modification.
Although Adam, I think even this CRC thing that would change the on disk format, right?
Yes and no. I was thinking about just software modification, I mean, without on disk format, of a change that will basically move front of blob to a different position. But I was pretty scared that it's never going to happen in current code. I mean, it's that we are not prepared that we can move blob starting point to another place. Because if we could, then for blobs that we currently have a front completely unused, I could just start that blob in a different offset and just start with the actual encoded data.
Yeah, but this might affect different scenarios when, so the idea is to have some spare chunks in a blob, or in other words, to have blob start in a fixed position. This helps to, if I remember correctly, it helps to reduce the amount of blob object instances in some cases. So instead of the idea behind that implementation was to be able to reuse these blobs and for later writes. And if you don't have gaps, or if you have blob starting at arbitrary position, this prevents us from blob use.
Well, I don't think so. If I can cut blob and move the position, then I can also extend blob by moving starting position. So that seems to still hold. I mean, the only thing that I agree should be preserved is that I shouldn't chop my blob into, like, let's assume I have 3 allocation unit modification in one blob spread over a bit, then I should not basically create 3 different blobs each allocation unit, because that would be inefficient.
But I don't remember the details, but it seems that hard or even impossible to extend blob from the beginning. So we can do these tricks with the tail, but not with starting. there were some issues with that, if I remember correctly. Not sure if it's
okay. I can temporarily accept that, but I will take a look at the code. What could be the actual places that prevent us from doing that? Because otherwise, the data format change, and I don't like it.
Well, data format change is probably not a big deal if this only impacts the encoder encoding decoding. So if there are no cross references to other stuff, or you just need to raise the format of the encoded chunk blob, then not that severe. So maybe
I mean,
yes,
we
maybe
can.
maybe it's in this specific case, maybe it's even better to update formatting encoding rules other than modify the processing logic, which might have much more impact.
Yeah, certainly, because I was able to do the former in 3 days, but for changing in logic, I expect more like weeks. That's the PR with just a hand modified encoding change.
Suggestion: did we consider the option of not using Snap for RBD mirrors? I mean, creating Snap every 15 minutes and deleting them is extremely expensive operation. I mean, it's not the only way to implement RBD mirroring.
That's exactly what I was wondering, Gabby, is maybe the answer here is to go back and say, okay, we tried to see if we could make this fast. We can't make it fast without significant changes to BlueStore. It never should have been done in the first place. Maybe that's the answer that we have to give. I don't know.
So you could do a very simple thing, like, I'm not saying it's the best solution, but just like from like 5 minutes planning. While writing, you could duplicate the write. Everything that you want to do could be written to some kind of a cyclic log buffer, and then in the background you could push that thing.
Well, there's like a journaling mode, right? There's some kind of
you can write a journal. So you every write you want to do to the primary you do normally, and then you also send the same write to the journal. And if we want to be nice, we could even make a special command for the OSD, so the OSD would split the write into the journal. And then the journal will have checkpoint, and you have some background process on the OSD itself, sending them to the remote, so you don't need the client, the RBD, to do the mirroring, because why should you read it? And so you have now, the moment is the RBD is reading from the OSD and then send it to the other one. So if the OSD knows that it has to do the snap, it could use this journal and then push everything to the remote when they have the time, and they have checkpoint, and they can have point in time. I mean, that's just something which I know it's like dumb. Probably I didn't do any smart calculation. There's like gazillions holes in design, but if we spend 2 weeks designing it, I'm sure you could find some different solution. Sometimes you do solutions because it was straightforward to design them and they worked, but over time you realize after some time it wasn't the best solution. At the time it was good to do it because it gave you a chance to do things quickly, but eventually you go back and you say, you know what, let's refactor this thing and do it differently.
Yeah, I don't know. I don't even know who on the RBD team would do it. On their side.
Doesn't even have to be them. It could be done on Rados.
Oh, Sure, but someone would at least
Why
need
don't
to
you just
implement
have a
the.
flag so you can set a write to the Rados to OSD, and they're going to be a bit saying this thing should also be mirrored to somewhere else, and then the OSD would write to one place, keep something in a journal, and there's going to be a background process on the OSD pushing thing from the journal to the remote whatever.
Just a side note, I can hear some similarity to PG log stuff. So
Yes, it sounds like it.
Sorry, I didn't hear Igor.
huh?
So I didn't get what you're saying. Your microphone
I mean, it looks so from your words, it sounds like there is some similarity to PG log stuff. So the idea to log the modifications on the object to keep
Yes,
tracking
actually,
them.
it's exactly this because we know how to replicate from primary to replicas. So RBD is essentially replication, but it's remote. But it's essentially the same. But I wouldn't, for one thing, I wouldn't use RogsDB for this. I would use a journal file.
Well, that's implementation details.
Yes, but you're right. You're 100% correct, and actually didn't think about it. You're absolutely correct.
Yeah.
We already know how to replicate, to mirror data from primary to secondary. So replication is another mirror, it's just a remote mirror.
Yeah, I mean, so if we are dreaming about a completely different implementation, and completely different design, we might say that glog stuff and this rather mirroring stuff, they might employ the same low-level mechanics to support that.
I'm just saying it's something we need to consider. I'm not saying it's a good idea. It might be a very dumb idea. But before we try to go and optimize something for a use case, which is inherently complicated, maybe we should rethink what we're trying to do here.
I will say that we've in general gotten feedback about snapshots being slow and problematic. So beyond RBD Mirror, there is some general sense. This isn't in isolation. I think people are suffering when they end up with a lot of shared blobs.
Yeah, sure. I don't disagree that we need to make Snap better, faster, more efficient, but I wonder how much better, faster we could make it with 4KB allocation unit. My guess is that you just going to get, I don't know, some extra space, it's going to be more efficient, but it's going to hit the same roadblock. You're just going to get later to the roadblocks. So it's not going to take you 2 hours to get there or 12 hours. It's going to be 24 hours. But if you keep running RBD, and RBD Mirror is just running continuously, we've seen after 12 hours this thing is bad. So let's assume that Adam and Igor are going to make things much, much better. So it's going to give you not 12 hours, but 24 hours, maybe 2 days, maybe 1 week. But if RBD Mirror is continuously running, you cannot do this thing.
We hit a saturation point. Basically, once you hit like the same number of shared blobs as extents. So say if you've got a 4 megabyte object and you do this pattern that we see with random writes, eventually you end up with almost 1024 shared blobs with one extent in them each, essentially. Not quite, it's close, but it's roughly that. That's where we hit saturation, it looks like.
So do we think that changing the way share blobs are handled going to eliminate this problem or just going to delay this thing happening?
I think it's bounded. I don't think that we continue to just use more and more CPU forever. Once we get to the point where we have as many shared blobs as we can possibly have, or close to it, that's when we we end up basically, hitting the limit. But it causes a lot of disruption for sure. High CPU usage, a lot of work during dupe.
I was just thinking of getting that maximum level a lot lower.
Yeah. And Adam, I had the opposite thought earlier today. I was thinking, well, if we're going to end up at the maximum level anyway, what if we just optimized for the idea that you always have lots and lots of shared plops?
Well, that could strangely also work because any customer would be upfront aware of operation cost. Then could factor that into operational routines and procedures.
Well, I was even thinking if you just assume that you have basically a shared blob for every extent, can you make it certain things simpler at that point?
Sorry, no. I mean, yes, but please.
It's just going to mean that it's like if you decide that all the cars can never go faster than 10 miles per hour, then you're not going to see so many collisions, but you are going to be slow.
Yeah.
You're not going to be surprised by, oh, today I had bad traffic, because you're going to have bad traffic every day.
Yeah, that's the situation we end up in these tests.
No, actually, the traffic will be good, but although slow.
Yes. But that's the situation we're in, right? With Paul's tests. That's what we end up in eventually is basically a shared blob for every extent.
Yes, and for me the question is whether we can prevent such a case.
Yeah.
Will the prevention procedure actually give us any performance boost? And side quest is what levels of complexity that we do not actually use, we still employ to provide for shared blobs.
Yeah. And yeah, I mean, I'm admitting this. I'm being kind of ridiculous here, but my thought process was, well, if you knew that this was the case, then could you make the stuff sitting inside shared blob and rough map maybe not so heavy anymore if this was kind of your just the way it is. But it's probably like you said, Gabby, it's maybe just being a little ridiculous. I don't know.
You might be able to optimize some flows, but not in any meaningful way. If you have that many share blocks, you are going to be slow. And Adam, do you think the change that you guys are suggesting is going to eliminate this problem, or is going to just give us more breathing room, but eventually you're going to hit the same problem? If we keep hitting the same procedure, so RBD Mirror is issuing a new snap every 15 minutes and is doing continuously random write, are you going to eventually get to the same problem, or it's just not going to happen because you have a solution which guarantees that this thing could not happen?
I mean, if you refer to the issue that it gets more and more computation intensive while we go, then no, we cannot eliminate that. But what we could hope for is to reduce fourfold amount of CPU needed to do it. That's what might be a target.
If I keep doing so, if after 12 hours I'm getting to this problem, so you are 4 times more efficient. So after 48 hours doing the same workload, would I get?
No, that's not how the maximum works. Okay, after 12 hours, you will get to the software that is slower, although it's still 4 times faster than current implementation. That's my thinking on what can happen if we properly get rid of burden with excessive amount of shared blobs.
My question for
In
you,
48 hours, you're going to stay in the same point. You're not going to get degradation from that point.
Yes, there is a saturation point, as Mark said, and after we reach that saturation point, intention is that it will be much lower. I mean, saturation point will be the same. The effects of saturation will be, maximum effects will be lower.
Okay, so you're going to get 4x improvement, which is very, very significant. But is it enough for our case? Because Paul was showing me 24x slowdown. So now we're going to be 6x slowdown. I mean, it's huge improvement. I'm not saying don't do it. I say definitely do that. But what about the 6x slowdown? Is that acceptable? And again, if you got 4x improvement, then never stop from doing that. You must do that. But why not go to a real solution with the journaling, which probably should be, in Wall's case, 2x slower?
Adam, I wanted to ask you, before we get into the performance specifically, does your change actually reduce the upper bound on the number of shared blobs that you would end up with per onode?
Theoretically, yes, it does.
It does.
Because if in reuse case, there should be at most as many shared blob per the default region of shared blob size as there are copies of object. No more, because if you have more, then you should be able to find a space in a shared blob that you can fit your new data in.
Okay, so like right now, the upper boundary, right, with a 4K min alloc size is 1024 shared blobs for a 4 megabyte object, right?
Yes.
And with your scheme, what would we expect the new upper boundary to be for the number of shared blobs that we could hit per object?
Upper boundary would be amount of shared blobs per object, meaning 4 megs per divided by 64K times the amount of snapshots we have live. But that's the upper bound, not the expected value.
Okay. Okay. So I think the upper bound is technically still the same if you had unlimited, as you approach an infinite number of snapshots.
Exactly. Right? If you have unlimited amount of snapshots, then you will certainly require to have each shared object in separate bucket.
Yeah. Yeah. And there's nothing we can do to fix that. But your expected number with a lower number of snapshots would be lower.
Significantly.
So Gabby, getting into what you were saying about performance, I guess this change is as valuable as maybe the number of snapshots that you're keeping, inversely to the number of snapshots you're keeping.
I don't understand what's the relation.
The reason we think that it's slow is because of the amount of work we have to do as the number of snapshots increases.
Yes.
So the hope is that if you only have like 1 or 2 snapshots, you can have significantly fewer shared blobs than you can now. But as the number of snapshots increases and approaches infinity, the closer you get to having the maximum theoretical limit of shared blobs per object that you did previously. So right now, after like 12 hours, right, we hit close to 1024 shared blobs per object. It's not exact, but it's pretty close. It's like around 1,000. Whereas with Adam's change, you would have a lower upper boundary at a low number of snapshots, but as the number of snapshots increases, the closer then you get to that one, like 1024 limit upper boundary that we have now. Does that make sense?
So you'd still get to 1024 shared blobs, but it would take longer. And then in addition, even when you have 1024 shared blobs, you're going to be 4 times more efficient processing them.
I don't think it's exactly that. I think it's that
Okay.
your upper boundary.
I will interrupt.
Okay, go ahead,
There
Adam.
is an important extension of what I did in that simulation.
I can't hear you, Adam.
Oh, sorry. Hello.
You cut
How
off.
about now?
Now you're fine.
Resolving network problems. Better?
I think so.
Okay. The case is, let's assume we have 4 meg objects. In that, we typically have 4 megs per 64K. How much is that? 256, I guess. 256 times 64K. So we have 256 shared blobs when we are having shared blob. And now, when we start writing to one of those blobs and make snapshot, then we have only in one snapshot a copy. So in our current situation, we had that writes in different places, and we get more and more shared blobs throughout a span of entire object. But with the change that is trying to reuse space in already used shared blob, once you had all the same variants, you just had one shared blob that was snapshotted 6 times, and there was nothing changed in it, then it should be basically the same. It should revert back to the original variant. It will no longer be fragmented. That's the thinking here.
So like there's like a hard upper limit on the number of shared blobs, and then there's kind of like a soft upper limit based on the number of shared, or for the number of shared blobs based on the number of.
Based off the workload, yeah, definitely.
And right now it's like we don't even have a soft limit, right? We just, as we go, we just fragment up to the maximum. Whereas with yours, if I understand correctly, you would have a soft limit below that hard limit that you wouldn't go beyond, but it would increase as the number of snapshots increases.
An amount of active snapshots increases, yes.
Yeah. So that would be the savings, Gabby, I think. I don't think it's that you process snapshots faster, but maybe we can do that too. It would be that your soft upper limit on snapshots would be now lower than the hard upper limit.
Correct. There is still question how faster it's to process one shared blob that has 16 different allocation units than process 16 small shared blobs.
Yes, we don't know that either. It will make the get and put calls inside the ref map more expensive because we do well, for the current implementation with map, actually it would only be the lower bound that would be slower because insert should basically be the same cost.
But one blob is one RocksDB key, 16 blobs is 16 RocksDB keys.
Sure. And the while loop would take longer because you'd be walking over more.
Why is a blob? Why there is one RocksDB key per blobs? Blobs are kept inside the object node.
Shared blob per shared blob is one. I mean, there was a mental shortcut. We were talking about shared blobs for so long that I possibly forgot to tell it's shared blob.
So shared blobs, each one get its own private RocksDB key?
Yes, for tracker.
Do we need to use RocksDB for this?
Yes, we do need some place to store it.
Why? I'm not saying someplace. Someplace is always good, but why do you need RocksDB? Why can't we just maintain a memory table tracker? You know, like the same style we did for allocation map, the same thing I'm doing for Snap Mapper. Why do we need RocksDB for everything? I mean, we could recover the table in disaster as we already scanned the object node, and the in-memory table will be much faster than using RocksDB.
Okay, because if we were to recover that from restart, we would need to keep in memory all the shared blobs.
Yes.
And now we don't do it. We just load the key with shared blob if we hit it.
It could get pretty memory expensive if we're really
Oh, so you
can
say
get like a
there
shared
be
blob.
too many of them to be kept in memory? Is it what you say? You say there's too many of them and we need too much memory for this?
I don't know. I'm just telling you what the result of not storing it in RocksDB will be.
So let's assume we have some kind of a hash table, and then the hash table will have pages, some of them in memory, some of them out of memory. Because RocksDB is extremely expensive mechanism.
What you propose now does not look like an easy solution.
Nothing is easy, but I know RocksDB is always the easiest solution, but it's the most expensive. I don't drive Mercedes, even so it's a much better car than mine. Better, but I'm compromised.
Gabby, if we were going to go to that extent, then I think my question would be, if we're doing that much work, maybe, or is it time to start thinking about like getting compression out of shared blobs, or even just looking if we can eliminate them entirely? Like there was a time with Blue Store before it even had blobs, when it was just shared extents. And I keep questioning whether or not that was the better route instead of what we're doing now. But I don't know. Maybe not. I mean, we did it for a reason. I just don't totally understand the reason, I guess.
Shared blobs versus shared extents?
Yeah, why did we implement another level of abstraction? And this gets back, Adam, to what we were talking about when you said that shared blobs is referencing direct disk offsets, right?
Sorry, guys, I used disconnect button as a mute button.
Oh, no, Adam, I was wondering, so what we were talking about earlier, you were saying that shared blobs are referencing direct disk offsets, right?
Yes, they do.
And I don't understand why we have so much abstraction, if that's what's going on. Why aren't we just using extents?
I mean, historically, I could imagine how it worked, because you could think, remember that we started from blobs like being 512K. And if you think in that sizes, then having one shared blob that encompasses entire region really makes much sense. You trade so many allocation units for one region of object that says this is shared part, and it is in multiple objects, and we don't want to just iterate over so many elements.
Sure.
That was me answering your question why we do have blobs for that usage.
I mean, the
Sure.
question is probably if the 1024 shared blobs per object is a reasonable thing to do. If it's a reasonable, then definitely go for shared extent. You gain nothing from the blobs. If it's a very crazy synthetic benchmark, then maybe shared blobs make sense. I don't know that they do, but it depends how many shared blobs you have per object. If it's 24, then it's definitely a bad idea. If it's 2, 3, 4, then yeah, sure, it makes sense.
Would there be any way that we could specify a minimum shared blob size and simply just deal with the space usage increase if we have to say that these two things diverge between the snapshot and what's the actual live object?
I would maybe say that once you reach these things, you should fragmentation. Maybe once you reach more than, I don't know, 64 shared blobs, you think maybe I should defragment this object and then get one single continuous.
Nice, but we cannot do that currently since we do not know who is an owner of the other references. You have your object that you see that you have a lot of shared blobs in your metadata, but you have no idea who else keeps the other references. So if you do anything with your object, you will still have no way to optimize the others.
If I'm going to add my memory table with active, let's put it just for the ones I'm doing fragmentation, then you can always check yourself in this table. If you're not there, then do whatever you want. If you are there, then you need something. And before you do anything else, you must put yourself to allocate an entry in the hash table. And then you don't need persistency or anything. Does it make sense?
I did not grasp your idea.
I'm saying if you wish to do something on a shared extent, any modification, you need to grab a lock, and the lock would be held in a global hash table. You query the hash table. If it's there, then you cannot take it. Or maybe you try to grab a lock if the lock is free. If it's not there, you're going to create the entry and have it locked. And then anybody which want to do anything which require modification on shared extent have to go to these things. No, actually, it's
okay.
Anybody. No, it's my bad. Once you defragment, it's require everybody to be quiesced. No, it's not a good idea. It's require that if all the active shared extents are going to be held in a memory table, then this thing is doable. Question is?
Well, my approach to even trying to be able to do such defragmentation was to somehow assign shared blob namespace for a single object. I mean, when you create object, you get a shared blob namespace, and then all the namespace shared blobs that you create for this object and all of the snapshots of this object will belong to the same shared blob namespace. That way, you will have a limited set of possible actors that do play a role in your shared blobs. And even if that was like 100 objects, you could still know that they share the same ID, namespace ID with you. That way you could optimize. But that was only me thinking, not even being close to try to implement it.
I mean, you could, in theory, if you move the data, you could move the data without locks. You just create a new allocation, and then you need to send a message to everybody which have share blobs that you change their location, and all of them have a
I
copy
don't
to you.
really care for live objects. I care about objects that are still frozen in somewhere in RocksDB metadata as stored objects. I cannot notify them. I need to pick them up and modify them accordingly if I modify their share blobs.
Yeah, and again, that brings my concept of in-memory table, not RocksDB.
I have to say, as we talk about this, I really hate how when we take a snapshot, it's like we have all of these references to the thing that is like the real object, right? I almost want that snapshot to be an immutable thing, and what's live maybe can reference some of it, and then maybe doesn't, like if it's changed. But I want to be able to make the decision about
Wait,
how of the
snapshot
new.
is an immutable thing. I cannot write to snapshots.
Well, it's
I've
yeah.
tried, and it says read-only file system.
No, I know, but what I mean is that like I I don't I don't like that we keep up all of these references to like little blobs of things, and we have to have them grow over time because we keep making modifications to the new thing. Like the new thing then makes it so that now we have like everything divvied up in weird ways because we have this old snapshot that has old, different data. It's like it feels like instead we should have like this solid base that then when we create, like when we modify an object or change something new, then we maybe have some old portion of the data that we can reference, but maybe we don't, and maybe we actually create a whole new copy of it instead, rather than trying to pick at little bits of the old one. Does that make sense?
Okay, I will try to rephrase to find out if I understand. You would prefer to have only one head object always and not create additional objects that are somehow related to the head object as we do now, but actually create just an empty shell that is somehow referencing the parts of original object.
Maybe that might be kind of along the lines of what I'm thinking. I want to be able to really easily say, I don't want to have references to all of these little chunks of the old object. I just want to make a new one and then have this other thing checkpointed in time, and that no longer matters anymore. Like I don't want to have to divvy things up into all of these little pieces because we have 4K of data here doesn't match the 4K data there. At some point, I want to just be able to say, okay, let's start over fresh.
I'm not sure if this is not human level way of thinking about it, but not really machine implementable. I have to think about it if we can modify our approach that way. Because I feel like when boiling down to implementation, it will basically be the same.
Maybe.
You still have to remember what you had, and the new ones need to know what's modified, but you don't want to have a head object being an update of some frozen object. You want a head object to be actually real and just like make a backward difference for the other objects. But can it be done? Like you set some OMAP data for your head object, you might think that, okay, I do set new OMAP data for head object, but I will note that the previous object had set it back the different data that it had before. Like this.
Well, okay, so like Adam, here's what the problem I'm thinking of is like once I get to like say I've got a 4 MB object, and once I get to the point where I've got 100 shared blobs for this thing, I don't want it to care anymore about referencing the old thing. I just want to make a new copy that then is, you know, one big extent. Because
Oh,
this other
so
thing,
sacrificing space for performance and readability. Okay.
yes, get rid of all these references. I want to say I don't care anymore. I don't want to maintain all these references and all of this chopped up little bits of blobs everywhere. I just want to start over.
So you disconnect. You
Yeah,
disconnect. You create a new head object. It's
yeah,
like a collapse thing people sometimes do. Like you collapse all the layers into a new object, and you hope that all the old snap eventually will be removed and they're not going to affect you.
yep.
And RBD mirror, that's actually going to work because you know that the old snap's going to be removed. I think actually it might help us.
What do you think, Adam? That's I don't even know how we get there, but that's what I want is something like that.
I don't know yet.
Okay. I don't know if I want it. That's what I think I want. But my
I
thought
guess
is,
it basically depends on what alternative action we could do. That's main thing for me.
Igor, what do you think? Is that okay or not okay? But is it ridiculous?
That might be interesting if we definitely can see that at some point we want to sort of compress this metadata, shared block metadata, so it grows to some point where it becomes ineffective. So this again brings some complexity, since you need so in terms of implementation, it brings some additional complexity. In terms of any performance benefit, it requires investigation.
Would we achieve almost the same effect if we just had a minimum shared blob size that was big? Like we said, you don't have a shared blob size that's less than 64K or something. I don't know if that's quite the same.
No, because you still will be creating new shared blobs, fragmenting.
Yeah, you just have fewer of them, right? Or you're saying that you fragment inside the no.
When you write something to object and you make snapshot, currently you create new shared blob. But I will go completely opposite direction. How would it behave? Let's forget for a second how we use shared blobs. Let's assume I have one shared blob tracker for entire object. Each time I allocate something to this object, I reference my shared blob counter, deallocate, I remove it. And I have just one huge shared blob tracker for entire object. And that's it. I will never fragment it. It will be always one. When I snapshot, I will reuse it and will be tracking it.
I'm confused, Adam. When you have one shared blob and you do a snapshot, how does
I first of all, I mentally did disjoint two things. One, shared blob tracking that we use to reference how many times we use specific disk offsets in a shared blob. That's one thing. And the other is that we use shared blob inside blob implementation just for data keeping. And I want only to talk about that shared blob that is tracking disk usage. That part. That's the type is called BlueStore Ref Map T or something like that.
Yeah.
And my thinking is I will have only one that shared blob per object. When I allocate, I put it in. I mean, maybe only when I do first snap, let's assume first snap, I do create that tracking, and that tracking object tracks all the allocations that I keep in my object. So when I do snapshot, I just add one to what I already have in my current head snapshot. And when I delete some object, of course, snapshot inherits that shared reference to that tracker. And when the object is deleted, it just removes itself from tracker. And now it works the same. If the tracker goes to 0 at some region, it means allocation unit is to be released. A transaction that did that.
To make sure I'm following you, you basically move the ref map out of the shared blob and into the O node?
Yep, exactly. To all the O nodes that share that come from the same object.
So you mean instead of multiple shared blob instances per object, you get single instance, which is a sort of mapping and reference counting, so something like for existing extent we keep n references.
Exactly that.
So what we save this way is amount of shared blob instances. So we might get less and this also applies to regular blobs since they keep this fake shared blob instance as well. Now the question is how to, well, first of all, we might get some performance so we might get some performance overhead when maintaining this mapping inside that single pad, whatever. So it should keep larger container and also the question is how to make it persistent. So if we keep one-to-one mapping between such an object and ProxDB record, then we do encode decode much more data on each blob, increment, decrement. Alternatively, it can perform n to n mapping, similarly like we have now for shared blobs, but we do not expose that to node level. So, well, the only benefit I can see for now is the potentially less memory footprint in this case.
I mean, this solution does not actually require to have one touch tracker per object, but it definitely requires. So the tracker is perfectly segmented throughout objects. So you could imagine like every 4 megabytes or whatever the object size is, you will have one tracker, but it cannot be fluid in the sense that, for example, we are fluid with resharding. It has to have fixed boundaries. Then we could offload some requirements for larger encoding for the larger tracker.
You mean amount of entries? Amount of entries in this object is bounded. So, well, first of all, this shared object is to be shared between every node and its snapshots, right? So we have
Correct. That's the exact use of it.
okay.
It works exactly as the same way as shared blob reference counter.
And if this means that amount of shared blobs in this shared object is not limited. So it's actually amount of snapshots, multiple amount of blobs, maximum blob multiple maximum amount of blobs per node.
And no, there is no part when you multiply over amount of snapshots, because all the snapshots share the same object. It might be that you will have some segments if you decide, but it's fixed.
Yeah, maybe. But again, what are the benefits? So we do not keep tons of shared blob instances, right? Anything else?
Yes, we no longer even track that there is something like shared blob.
Yes. So we keep that embedded into this single object, in fact, and into this shared object.
This single tracker, I will call it tracker now.
Yeah. Okay. So yeah, and again, the benefits are amount of instances. So we do not need shared blob, tons of shared blobs. But what else? Oh, that's enough.
I guess
I mean internally this shared tracker should be pretty similar to the current shared blob. So it should keep a sort of mapping between offset and reference count, and it should provide sort of persistency for this mapping, right?
Agreed.
And probably it's not efficient to make it persistent. So it's not. It might be inefficient to encode this full map on each shared block operation. So it should implement something similar to what we have now. Is a bunch of ProxDB records for tracking this. So this runtime map, this single runtime mapping should be mapped to multiple persistent ProxDB to be efficiently encoded, decoded.
I agree that possibly having actual one, as I deliberately started telling about one to make it simpler, but I think one will not work. It should be somehow segmented to various offsets of an object. But it has to be fixed so all the clones will know when to access, when they will reference or dereference disk usage.
Adam, all of a sudden it sounds a little bit, so in the background as you guys have been talking, I've been thinking about how nice it would be if you created a snapshot. It was like this fixed thing with fixed size regions that were compressed, and then you just had like, the ability to use it. So like say 64K or 128K or whatever. And then when you took a snapshot, the new version of your object could or could not choose to use one of those depending on whether or not it's changed. But it's not like it is now where it divvies up ever smaller. It's just a fixed size. Is that unlike what you're talking about?
I don't get your concept. You are talking about a different approach to compression now?
No, sorry, just forget the compression part. You just have fixed size regions of the original data that's like your shared blob, but it's when you make a snapshot for what you now have as your current live object or whatever you want to call it, I guess it can or cannot use those, but it's not like you divvy them up smaller. Does that make sense?
No, sorry. I'm sorry.
Okay, never mind.
Please
Go back to your idea. Let's forget it for now. Go back to your idea.
Well, in fact, I like Adam's idea to make single instance for tracking shared objects per namespace. So, far as I remember, we have plenty of shared blob references and fake shared blobs. Help us in reducing memory footprint.
And you know, guys, what? I could even implement some POC reasonably fast.
I think you should try it, Adam. I've become convinced that the only way we're going to get through this is to just try many different things and see what works.
Oh, one thing, a bit of topic. Igor, I noticed that we have a clone range function that allows to copy a region of one object into another object and change offset. I have some doubts that this is implemented correctly. Do you know of cases when we actually use this clone range with move practically?
I don't, but my feeling was the primary target is not to move to different offset, but rather sort of snapshotting, but for a range for objects.
Yes, because all the usages I've seen and all the unit tests I've seen, they always have the same. The destination offset is the same as source, and it makes perfect sense for all snapshots and also for cloning regular objects. To move offset, you will actually do some. I don't even know what you can achieve if you clone object but move offset.
Yeah, and I believe it's not used.
Okay, guys, do we have any more topics for today?
No, I'm pretty exhausted.
Igor, it must be either later for you than for me, I guess.
Yeah, it's 8 p.m., almost 8 p.m., but I generally tend to work later than earlier.
As do I, all because of my American colleagues.
Thank you guys for thinking of us. Well, I suppose, Adam, I think you should try it. I don't know. I'm trying to decide if I want to even attempt some of the things I was just thinking about in my head. Maybe. I'm not sure if I should continue to try to poke at the ref map, and I had a couple of ideas for trying to maybe make a vector implementation of it much faster, but I don't know if it's really worth doing or not. Especially if we're going to change the properties of how we use it.
Well, if I test it, then it will definitely not go direction of being small.
Exactly. That's what I was thinking too, is that then it's just a decision, I guess, of how you access it. If you're really accessing it like a map, maybe an intrusive map or a map is a much better choice if it's large.
Okay, Mark, I will test and I will share soft with you if it's good enough to be doing anything.
Sure. Okay, sounds good. Thank you guys for the discussion. Hopefully we make progress here.
Thank you, Mark. Thank you, Igor. Have a nice weekend.
Yeah. Have a good weekend, guys. Bye.
It's one more day, one more working day.
We at Red Hat we have a day of learning tomorrow, so we get to learn other things.